A resin 3D printer turns a liquid photopolymer resin into a solid object using patterned ultraviolet light. Once your print is complete, you wash it in an isopropyl alcohol bath and then expose it to ultraviolet light for a few minutes to fully solidify. The goal of this project is to create a UV curing station, a chamber you can place your print into to get that final dosage of ultraviolet. The basic hardware premise of this project is we have a UV LED strip that is turned on and off by a microcontroller. To accomplish this, we use a 3.3 volt relay module that takes in a GPIO signal to connect or disconnect the UV LED strip circuit. One small complication is that the UV LED strip circuit runs off a 12 volt DC wall adapter, so we use a full bridge rectifier and a linear voltage regulator to turn that into 3.3 volts to power our microcontroller. Finally, we have a graphical LCD module with a 176 by 220 resolution and full color capabilities to convey information such as joystick input, time remaining, and LED status. To accomplish this in software, we have two primary paths of program flow, the main loop and the timer ISR. In the main loop, we initialize our peripherals and then wait for joystick input. Pressing up will add 30 seconds to the timer. Pressing down will subtract 30 seconds. And pressing in will start or pause the timer and turn the UV LED strip on or off. Meanwhile, the graphical LCD will be updated to reflect the current state of the system. While the timer is active, every 1 second we will enter into the timer ISR, where we decrement the timer and then check if that timer has expired. If so, we need to turn off the LED strip and stop the timer. Now, a little more detail about the new elements I implemented. Firstly, we have the relay module, which was quite simple. I did have some issues with faulty hardware, but otherwise it was straightforward to use an MCU GPIO signal to control a higher voltage circuit. Second, we have the ADC joystick, which is built into the MCU I selected. The joystick uses a simple voltage divider to generate a specific voltage depending on which connection the joystick has currently closed. Setting up the ADC pin in software was not much more difficult than setting up a generic GPIO pin. Lastly, we have the SPY graphical LCD, which I found to be the most difficult part of this project. I spent a couple days fighting with this thing, then eventually found success using a logic analyzer and an existing Arduino library. I used the datasheet and that library, which is credited in my code, to get to the point where I could draw a single pixel on the screen. From there, I devised my own functions to draw shapes and icons. I learned how to generate bitmaps from image files and use my own drawings, like you see here, to display the joystick, the timer digits, and the light bulb. And with that, my project was complete. It's fully functional, and I actually used the curing station to cure its own 3D printed handle. Thanks for listening.